Hello everyone, my name is Aziz Burmila from Palestine. I'm a master student of architecture in Gurn American University at North Cyprus. I'm happy today to participate in this conference. Today I'm going to talk about the urban configuration and residential building efficiency, a case study in Palestine, Hebron city. Hebron is one of the most ancient inhabited cities located in the southern West Bank. Hebron has a high urban density and geographic constraint, which limits the expansion of the city and intensifying building concentration. Since the mid 20th century, Hebron has experienced rapid urbanization due to population growth and internal migration into the city, beside the land scarcity caused by occupation and settlement activities. The built environment shifted from compact, culturally embedded patterns to more irregular and denser ones. The implication for efficiency. Number one is the spatial form, street networks, lot shapes, building height, and spacing directly affects energy demand for heating and cooling. Building in high density areas experience limited natural ventilation, reduced daylight access, and higher cooling loads. Number three is Hebron lacks effective urban planning due to political constraints and outdated planning policies, making it harder to align the spatial growth with sustainable energy goals. As shown in the picture, the H1 area and the different urban form for the city of Hebron. The aim of the study is to analyze the impact of urban configuration on the energy demand of the residential building in Hebron city by identifying key urban form variables, classifying different urban patterns, simulating energy consumption, heating and cooling, beside drawing conclusions about the efficiency or inefficiency of existing urban patterns from an energy standpoint. So, to study this relationship, we have two questions to raise. Number one is, how does urban form affect the energy performance or residential building in Hebron? So, a shortcut answer is called saying that the spatial structure is a major determinant of how buildings consume energy. Parameters like building compactness, open spacing ratio, orientation, and density influence thermal performance. Now, the second question is, what role do cultural and planning factors play in shaping Hebron's current urban configuration? The cultural transition from extended to individual family, the privacy norms, and the gender role deeply affect and play a role to the residential layout. Planning in Hebron is shaped by fragmented legal system, occupation-based constraints, and the absence of cohesive policy enforcement. When it comes to the methodology, the methodology involves an integrated multi-layered approach that combines spatial analysis, energy simulation, and urban morphology theory. Starting with research design, a mixed method design combined both quantitative and qualitative techniques, spatial analysis using GIS tools, comparative morphological and cultural analysis of selecting urban neighborhoods. Number two is case study areas that focusing on three areas actually. Each one is representing a different urban patterns. We have number one, the Old Town and Al Sheikh neighborhood beside the third one, which is the Al Zaytun neighborhood. Each one has a special specification for its urban form. The theoretical framework is a framework linking urban form and efficiency. Urban morphology theory analyzing the form, the structure, and the evolution of cities, beside includes the spatial patterns, lots, streets, and density. Number two is spatial indicators, FSI, GSI, OSR, and building height, measured using GIS, and they are used for assessing the efficiency of built environments. Energy and Climate Design Builder, a simulator software to measure the performance of the building, connects the morphology to energy performance. And the last one is the cultural logic. Social patterns influence planning layouts. Cultural shifts reduce environmental adaptability. So here we have the three areas that we were choosing. If we look to the horizontal density of residential area, we see the highest one is the Old Town, and the medium one is the Al Sheikh neighborhood, and the last one is the Al Zaytun neighborhood, which has low horizontal density. Here, as it's shown in the picture showing that the most floors for the Al Sheikh neighborhood and the Old Town are the first floor and second floor, and most of the rest building are six, seven, or eight floors. But the most density areas showing that the Al Sheikh neighborhood and Old Town are similar to the horizontal expansion. But Al Zaytun neighborhood contains a lot of high-rise building. It's starting from 3 floors, 4 floors, and 5 floors. Here we have specific areas were chosen from the three main areas. So we have three areas from Al Sheikh, three areas from Old Town, and one from Al Zaytun. And each one we applied the indicators for the building efficiency to get a result from the measurements. As shown in the chart, we see here the density variables of different studies area. We see the highest one is the open space ratio for number 5, which is the Al Zaytun neighborhood, and it's a pre-planned area. Another chart showing the heating and cooling demand per year for the 7 small areas were chosen. So we have here a high heating load in each area, but number 3, it has a low heating load. Compared to the cooling load, we see that the main problem is the heating load in each of one in every area. And here we have the annual average heating load with the 4 urban variables. We see the open space ratio here also at pattern 5, which is the highest number here in this chart. And if we go back to the area specification, we see this is for Al Zaytun neighborhood. Another chart here showing the annual average cooling load with the four urban variables. And we also have here the annual average load with the 4 urban variables. We see the highest one also for pattern 5. When it comes to the ratio, the ratio shows that 0.3 for annual heating demand. It's the correlation between the energy demand and the built intensity. We see a negative relationship between the built intensity and annual heating demand. But a quite positive step toward the future, we can see a linear relationship between the annual cooling demand and the built intensity. Another correlation between energy demand and coverage. We see that the ratio showing 0.2 for annual heating demand, which is quite negative relationship. And it's like medium relationship between the annual cooling demand and the coverage. Another chart showing here, the results are quite negative in the both sides, the annual cooling demand and the annual heating demand when it comes to the correlation between the energy demand and the building height. And another chart here we're showing the correlation between energy demand and open space ratio. We see the ratio show that the result is 0.1 for annual heating demand and 0.5 for annual cooling demand and open space ratio. Another case study is still under development, and the finding will be mentioned in the full article paper at the end. This is a study for the cultural impact of the cultural life of Hebron city on the urban forms. 2 areas were chosen, Ras Al Jora, which is the modern one, and the old town, the old neighborhood, the other one. And this picture showing the density between the difference of the density between the old town and the new town or the new part of the city. Another picture here, we're showing the mixed use. It's showing the comparison between the old town and the new city. And the third one is showing the open spaces in the old city and the new neighborhood. When it comes to the findings, we're seeing that the results from simulation softwares and the urban variables actually showing the urban form has a direct impact on energy demand and the cultural evolution link to loss of sustainable spatial model. The extended family housing clusters created walkable, self-shading neighborhoods. Beside the shift toward nuclear families, individualism and car dependency resulted in spatial fragmentation and urban sprawl. Beside the traditional planning logic mixed use, passive climate control is being lost. The final finding is that traditional Hebron architecture is energy conscious and socially adaptive. Shared walls reducing energy loss, with courtyards enhancing thermal comfort and orientation toward privacy and sun. Traditional forms developed from experience and need, with maximum climate and social efficiency. My recommendation for this number one is reintegrate traditional urban principle to restore impact neighborhoods layout with passive climate design. And the other one is to integrate cultural value into planning regulation, incorporate privacy needs, family structure, and collective use into zoning and design codes. And here we reach the end of my presentation. Thank you for listening. Thank you for being my audience. Goodbye.